Hi, today we're going to continue our swap examples and we're going to talk a little bit about the turn of year effect and how this matters. And what we can notice is that when we are looking at, for instance, the dollar SEK, and we want to extract an implied discounting in SEK from the US overnight index swaps. We're just coming up to the year end. We can see implied interest rate effects, which are not at all that small. So let's have a look at what this looks like. We're going to turn to the swap calculator, and we can see that we have the dollar OES and we have the SEK OES, which we're not going to use, but we're going to use the implied currency implied discounting curve instead, which is the red one. And we can see that in the short end, we have years on the x-axis here. So we can see on the short end, we have a big spike down to somewhere around a minus 1.4 percentage points, which is quite big. And this is due to liquidity effects in the turn of year or the year-end effect. So can we remove this? Well, yes, we can. So we have then a turn of year effect removal tool, and we can now see that on the year end we removed about 60 basis points in the implied discounting curve of SEK. And we can just look at this and turn it back. Well, what you can also see that the spike removal is not, it's the net effect of the dollar and the SEK. Because we have FX swaps and FX bases that are dollar SEK as a cross, we're not really aware of in which currency this year-end effect is active in. So we're actually doing a net adjustment on the net of dollar and SEK year-end effects. And this manifests itself in having a spread that's the net of both. But in the implied SEK, you can see that it's a pure SEK implied curve. So this effect now looks much bigger here in the graph. So with this said, is this a good thing to do this? Well, it's a common practice to have smooth forward curves, and as such, obviously, it's a good thing. And especially in risk management, we don't want to have this turn of year effect in the historical samples when we do calculate the historical value risk, for instance, because when we pass the year-end effect and we still have these big movements in curves from before year-end to the after year-end, this will totally define the historical simulation tail events. And so you will have these tail events for the rest of the year then for all your risk measurement. And this we don't want, because this is obviously a market event that's happening and known around the year end and nowhere else throughout the year. So the move should be or could be removed in the risk measurement. But what are we missing when we do this? Obviously, we will miss in the pricing of these instruments that actually go over the turn of year. Because if we remove the turn of year effect from the implied discount curve, any FX instruments that encompass this turn of year will obviously have a discount factor that's wrong. So what we actually need is to have both for different purposes. You need to have the pricing curves, and you need to have some sort of cleaned risk curves that are valid for the rest of the year. And then you need to assess the size of the year-end effect before coming into this year-end effect period. So this is what I wanted to show you. This is a continuation of the effects that are active when you price, for instance, currency interest rate swaps, because this affects the implied foreign currency that you need to discount the foreign cash flows with. So in these cash flows, you will observe this year-end effect, especially close to the year-end. Here we're in November, end of November, and we can clearly see that if we remove the overnight forward over the year end only, the curve reduces to something which is looks much more plausible. Thank you very much.